Hello everyone. At last we are discussing about the ionization enthalpy as well as the ionic radii in the periodic table. Now in this lecture we discuss the electron gain enthalpy. Electron gain enthalpy means when we adding an electron into an element, that element adding the electron, then it will be release the energy, that means enthalpy. The definition of electron gain enthalpy is the enthalpy change that takes place when electron is added in an isolated gaseous atom and its ground state, then that type is known as the electron gain enthalpy. पाठीमागच्या लेक्चरला आपण आयोनिक रेडिया आणि त्याचबरोबर आयोनिक एन्थाल्पी बघितलं होतं. आता आपण इलेक्ट्रॉन गेन एन्थाल्पी याच्यामध्ये काय आहे, इलेक्ट्रॉन ऑफ एन एनी एलिमेंट. आता इथे काय होतं बघा, एखाद्या एलिमेंट मध्ये जेव्हा आपण एखादा इलेक्ट्रॉन ऍड करतो, गेन म्हणजे ऍडिंग ऑफ इलेक्ट्रॉन, आणि तो जो एलिमेंट आहे तर तो एलिमेंट आयन फॉर्म करतो. त्या एलिमेंट वरती जेव्हा निगेटिव्ह चार्ज वाढतो ते फॉर्म एनायन, निगेटिव्ह चार्ज असल्यामुळे तो एनायन फॉर्म करतो आणि त्या एनायन फॉर्म झाल्यानंतर त्यामधून एनर्जी रिलीज होते. ही जी रिलीज होणारी एनर्जी आहे दॅट इज नथिंग बट अवर इलेक्ट्रॉन गेन एन्थाल्पी. त्याला आपण काय म्हणणार आहे, इलेक्ट्रॉन गेन एन्थाल्पी. द एन्थाल्पी चेंज when we adding an electron into the isolated gaseous atom is nothing but our electron gain enthalpy. Now you understand by the examples what happens here. When we considering an element A, first example, the element A, when we add the electron in it, then the anion will be formed. A anion will be formed. That means electron here, if we considering the number of proton, number of electron, when we add one electron into it, the number of electron goes on increases as compared to the proton. आपला जो एलिमेंट होता त्यामध्ये आपण एक इलेक्ट्रॉन ऍड केला आणि एक इलेक्ट्रॉन ऍड केल्यामुळे त्याच्यामध्ये असणारी प्रोटॉनची संख्या तेवढीच झाली, फक्त इलेक्ट्रॉनची संख्या काय झाली, वाढली. आणि इलेक्ट्रॉनची संख्या वाढत असताना त्याच्यामधून एनर्जी बाहेर पडते आणि दॅट इज अवर इलेक्ट्रॉन गेन एन्थाल्पी. ते डेल्टा EGH याने दाखवला, डेल्टा EGH. आता आपण दुसरा एलिमेंट घेतला, B एलिमेंट घेतला. When we adding an electron into the B element, then we also have the B anion. B anion formula. याची सुद्धा एनर्जी जी आहे डेल्टा EGH. But the second B element having a higher energy as compared to the A. When we take an example, then you understand. See here, what happened here? The heat will be released from this reaction. This type of a reaction is our exothermic reaction. Exothermic reaction. And in a case of an exothermic reaction, when heat will be given out, goes out, then the value of delta H, the value of delta H is negative. The value of delta H is negative. Here also the value of delta H is negative. Sometimes what happen, when we add in electron, but that element C element. The C element, when we adding an electron into it, but that C element is stable. It cannot require any electron to stability. Then see here what happens when the C element take an electron. For taking of that electron, if we give the heat to that reaction, then the anion of that C element will obtain, but the value of electron gainenthalpy delta G H be the positive, because endothermic reaction will be occurs here. When the exothermic reaction is happen, then the value of delta EGH is less than that of 0. And if we adding the electron and giving the heat to that of a reaction, then the value of delta EGH, electron gain enthalpy, when endothermic reaction will be happen, the value of delta EG is greater than that of 0. इथं व्हॅल्यू निगेटिव्ह असणार आहे, एक्झोथर्मिक रिएक्शन असणार आहे, इथं व्हॅल्यू पॉझिटिव्ह असणार आहे, शून्यापेक्षा मोठी म्हणजेच पॉझिटिव्ह व्हॅल्यू असणार आहे. म्हणजे या टाइपची रिएक्शन कशी असणार आहे, एंडोथर्मिक रिएक्शन असणार आहे. नाउ वी सी द एक्झाम्पल. फर्स्ट A, if we are taking an oxygen, when we adding the electron in it, when we adding the electron in it, that oxygen have electrons, 8 electrons present in it. We add 1 electron into it, that oxygen anion will be formed. That means it have a totally 9 electrons into that. If we are write like this, 2, 6, that means first shell containing 2 electrons, while second shell containing 6 electrons. We adding 1 electron into it, then it becomes 2, 7. That 7 is not stable here. We add 1 electron, it form an anion, but it is not stable. If we are taking this second example of a fluorine, fluorine 2, 7, because atomic number, that means number of electron present in fluorine is 9. When we add 1 electron into it, that electron goes into the outermost shell and we are getting fluorine anion. See here, 2, 7 plus 1, 8. That 8, the first cell is stable, but the second, when we adding 1 electron into it, that also becomes stable. That means fluorine having the stability. When we add 1 electron into that, and releasing of heat energy or energy from this fluorine is higher as compared to that one of oxygen. Now the third example, we are taking by the C plus electron minus. In this type of example, the heat will be used to do this reaction. That means endothermic type of a reaction. And anion of C will obtain here endothermic reaction because we are giving the heat to that of the reaction. The example, if we are considering the helium. In the helium, when we add 1 electron, then helium anion will be obtained. But if we consider in the number of electrons present in Now these are the examples of electron gain enthalpies. Now some factors also affecting on the electron gain enthalpy if we considering the atomic radius. See here, if we are taking an example denoted by the shells, there are 2 electrons are present here. The outermost shell containing 2 electrons, and 1 electron we want to add into that. We want to add this electron into that. Now another example. There are 4 shells are present, and outermost shell containing electrons into that, and 1 electron we want to add into that. This electron also we want to add into the outermost shell. If we considering the atomic radius of this first one, if we are denoted by the element A and element B. In that element A, if we considering the atomic radius as compared to the B, the atomic radius of A is less. Therefore, force of attraction to attract that electron towards that is less as compared to the element B. Because the atomic radius of B is higher, that means 4 shells are present. Therefore, it will be attract electron into the 4th shell. It requires more energy. That means atomic radius increases, the electron gain enthalpy also increases. Now from the periodic table, if we considering the periodic table, in that periodic table, the atomic number goes on increases from left to right. That means atomic radius also goes on increases from the left to right. Then what happens? When atomic radius increases, the electron gain enthalpy also increases from left to right. Now from the top to bottom, if we considering the element from the top to the bottom, the electron gain enthalpy goes on decreases. If we are going from top to bottom, the electron gain enthalpy goes on decreases. Now we see the reaction form. That means if we considering the X as an atom, when we adding the electron into this atom, it forms the X anion. X anion is a formula. The unit for the electron gain enthalpy, that means delta EGH, is the kilojoule mole units. Kilojoule mole or per mole. Kilojoule per mole. If we considering the group number 17, group number 17, then the stability of group number 17 is goes on increases into the group number 17 because it requires 1 electron to getting the stability. But in case of the group electronegativity, the atoms having ability of an covalently bonded attract the shared electron towards itself. The ability of covalently bonded atom to attract shared electron towards it.